In the early hours of January 2026, just after 2 a.m., a major drone operation unfolded near the Bryansk-Navlia border inside Russia, where one of Moscow's key Shahed-type launch facilities was preparing what commanders expected to be another large-scale strike against Ukraine. Air raid sirens cut through the darkness as Russian crews moved through well-rehearsed procedures, loading fuel, confirming guidance systems, and readying platforms for what planners believed would be an overwhelming saturation attack. Moments later, more than 150 Giron-2 drones, Russia's designation for the Iranian-designed Shahed-136, began lifting into the night sky in dense, accelerating waves. Their MD-550 engines emitted a distinctive droning howl as the formation pushed west toward Ukrainian airspace. The logic behind the attack was the same that had guided previous mass launches: volume over sophistication. The Giron-2 is neither stealthy nor fast, but its low cost allows Russia to deploy it in large numbers, forcing Ukrainian air defenses into difficult, resource-intensive decisions. Each drone carries a roughly 90-pound explosive warhead and can travel up to 1,000 miles, turning it into a long-range flying munition capable of striking cities, infrastructure facilities, and critical power grids. Russian planners had aimed this wave at targets around Kyiv and Sumy, intending to overload tracking systems, exhaust interceptor inventories, and create exploitable gaps for future strikes. In the Navlia command post, officers watched their screens with confidence, believing the massed swarm would break through Ukrainian defenses as it had before. But within minutes, the underlying assumptions of the operation were already being challenged. Ukrainian forces were tracking the swarm with unusual precision, having identified this particular shipment from Russia's Alabuga production line days earlier through partisan intelligence, open-source monitoring, and satellite observation. Their planning focused not only on intercepting the incoming threat, but on seizing select drones intact. Ukrainian analysts understood the technological value of the MD-550 engines and onboard electronic systems, components that could be studied, adapted, and potentially repurposed. As the swarm crossed into the contested border zone, Ukrainian interceptor drones began to rise to meet them, systems designed not for explosive destruction, but for controlled capture through GPS spoofing, electronic manipulation, and physical redirection. The opening minutes of the engagement signaled a shift from conventional air defense to a more complex and risky operation. While much of Ukraine's defense grid braced for an intense saturation strike, a specialized team was already maneuvering to capture select drones without detonating them, initiating what would become one of the most consequential drone confrontations of the conflict. As the swarm advanced, Ukraine activated its new generation of interceptor drones, designed specifically to force hostile units down intact rather than destroy them. These low-cost systems carried GPS spoofers, electronic warfare payloads, and Kevlar entanglement devices, enabling operators to manipulate incoming drones by distorting navigation data and applying controlled physical pressure. One of the Ukrainian operators, known by the call sign Dima, guided his interceptor toward a target drone, working in coordination with electronic warfare teams who were already feeding the Giron-2 misleading positional data. His mission was to maneuver the heavier Russian drone into a marshy landing zone where recovery teams could extract its engine and guidance modules. The operation required precision because any excessive impact could detonate the 90-pound warhead. Dima selected only a few drones with the smoothest running engines, while the majority of the swarm continued toward Ukrainian cities and infrastructure. During these delicate maneuvers, a separate Ukrainian interceptor collided too forcefully with one of the Giron-2 units, triggering a large explosion that destroyed both drones. The blast served as a reminder of the risks inherent in Ukraine's attempt to capture advanced enemy systems during an active saturation attack. Meanwhile, Ukraine's broader air defense grid was under heavy strain. Patriot batteries were forced to fire high-cost interceptor missiles at comparatively inexpensive drones to prevent strikes on populated areas and critical facilities. Jeopard anti-aircraft systems fired continuous bursts of 35mm rounds, illuminating the night sky with tracer fire as debris fell across the region. Commanders were forced into difficult decisions regarding the allocation of expensive defensive assets, where dozens of drones threatened multiple targets simultaneously. Inside Russia's Navlia command center, the tone shifted when radar operators noticed that some drones were not being destroyed, but were instead descending in controlled patterns. Thermal imagery revealed Ukrainian FPV units escorting Geran-2 drones toward the ground. Russian commanders quickly recognized that Ukraine was not conducting a standard defensive engagement, but was attempting to seize technological assets. An urgent order was issued, instructing Pantsir S-1 crews to neutralize their own drones before they could be captured. Russian air defense systems began firing on the swarm, destroying many of the same drones launched only minutes earlier. In the escalating exchange, several Ukrainian interceptors were also destroyed by Russian fire. As Russian operators continued to send remote detonation commands, some drones exploded in mid-flight or just above the marshland. Dima lost multiple controlled targets, but he managed to maneuver a few drones into zones shielded by strong Ukrainian jamming. These units landed intact, their electronic links severed. Within minutes, Ukrainian special operations teams advanced on fast, low-profile vehicles equipped for rapid extraction under fire. Using night vision equipment, they reached downed drones in the marsh and worked to secure key components. Technicians applied liquid nitrogen to freeze fuses and electronic triggers, then sealed the drones inside portable Faraday enclosures to block Russian detonation signals. Artillery fire landed nearby as teams recovered 4 engines and several guidance assemblies before withdrawing into sheltered terrain. By the time Russian artillery intensified, the Ukrainian teams had already evacuated, leaving Russian commanders facing the reality that valuable components had been captured despite emergency self-destruction orders. In the days following the operation, Ukrainian technical teams began examining the captured engines and guidance systems. Instead of attempting to replicate the Shahed platform in full, Ukrainian engineers integrated the recovered MD-550 engines into upgraded Beaver long-range drone airframes. This approach allowed for rapid deployment of modified systems, without the delays associated with full-scale reverse engineering. By January 25, 2026, Ukraine had assembled a mixed fleet of 10 long-range drones, 4 powered by the captured engines and 6 built with newly adapted components derived from the recovered systems. At approximately 3 a.m., the Navlia launch base that had coordinated the earlier mass strike detected familiar acoustic signatures. Operators initially assumed that the drones were returning Russian units because the sounds matched those of their own MD-550-powered fleet. Automated alarms did not activate, creating a temporary vulnerability. Moments later, the Ukrainian modified drones reached attack altitude and executed precision dives toward critical launch infrastructure. One drone struck a row of Shahed launch racks, triggering a chain reaction of fuel and explosive detonations visible for miles. Russian air defense crews attempted to respond, destroying one drone in flight, but the entire facility was soon engulfed in secondary explosions. As personnel focused on aerial threats, a second wave emerged at ground level. 20 FPV kamikaze drones maneuvered through debris and targeted fuel depots, command vehicles, generator units, and radar systems essential to base operations. The strikes caused multiple fires and system failures across the installation. 2 additional long-range drones, equipped with captured MD-550 engines, targeted Pantsir air defense batteries that had destroyed Ukrainian interceptors during the earlier engagement. Both batteries were struck directly, resulting in further losses for Russian forces. The attack raised serious concerns within Russian command structures. Ukrainian drones, equipped with engines sourced from Russia's own production facilities, had bypassed initial detection parameters by mimicking the acoustic and operational profiles of Russian units. For 48 hours, Russia suspended Shahed-type drone operations along the northern axis, while analysts worked to develop new identification protocols to distinguish between Russian and Ukrainian modified systems. The incident highlighted vulnerabilities in Russia's reliance on mass-produced drones with consistent signatures, creating uncertainty about future deployments. The events at Navlia also marked a shift in the technological and tactical dimensions of the conflict. Ukraine demonstrated the ability not only to intercept and neutralize incoming threats, but to repurpose captured components into offensive systems that could strike high-value targets. The Russian command was forced to reassess the risks of self-destruct protocols, the exposure of launch facilities, and the possibility that future waves of Geran-series drones might be vulnerable to similar exploitation. The outcome underscored how the dynamics of drone warfare had evolved into a contest of adaptation, where captured systems could be rapidly reconfigured and used to undermine their original operators. Subscribe for continued coverage and analysis of developments in the region.